In this video, we're going to be describing classes in Python. Classes in Python allow us to define our own types of objects. A class can contain both data and functionality, just like a list, a dictionary, a string, or any other type that we've seen so far. To define a class, we use the class keyword, followed by the name of a class, which can be anything that we want, although PEP 8 recommends the use of cap words for classes, meaning that the first letter of every word in the name should be capitalized. So to see this, let's create a class called myClass. And after the name, we need to have a colon. And for the body of this class, I'm going to simply write pass, meaning that we'll come back and define this later. So to use this, we actually need to instantiate an instance of a class. We do that by creating a variable name and then binding to that name an instance of the class. So we'll create myClass and then open and close parentheses. This is going to look very familiar to using the list function or the dictionary function or so forth. But in this case, we're creating an instance of the class that we are writing. And so if I run this block, you'll see that the output simply gives us back the type of our class. So our class is currently empty, which means it doesn't have any data or useful functionality. So we're going to fix that now. When we add functionality to a class, we do so by specifying methods. Methods are functions, but they differ in that their first argument must be the instance of the class that they act upon. And because of this, when we define a method, we have to remember that the first argument must be present, and it's going to be assumed to be this instance of the class. So we're going to add a method f to our class. So I'm going to rewrite our class here, class myClass, and then a colon. And then instead of pass here, we're going to write def f, which is the name of our method. Following that, we need our formal parameter list. Now for this method, we're simply going to print out a string. So we don't require any arguments for this print. However, because this is a method of a class, we are required that the first argument be reserved for the instance of the class that this method acts upon. And by convention, this argument is named self. So I write self, I'll hit colon, and for now we'll simply print hello class. Now, before we get into what self is and how we use it, let's create a new instance of our class, and then we'll call our method. So once again, I'll use the name obj, and I'll say equals myClass, then parentheses. And now there are two ways we can call our method. The first and most common is to use the dot notation, starting with our instance, so obj, then a dot, and finally the method name itself and its argument list. Now notice that I'm not passing an argument for self, yet when I run this, it still works. So the reason that we're not required to pass the argument for self is that we're using this dot notation with the instance. So the fact that I wrote obj dot followed by the method name means that Python will supply obj as the first argument for us. This is sort of a syntactic sugar so that it's easier to read that this method f is being applied specifically to the object obj in this case. And now the second way we can call this method, and this is much less common and by far not the preferred means of doing so, is to call the method using the class name and then explicitly pass obj as an argument. So I write myClass dot the method name, and now we specify obj explicitly here. And when I run it, you see that this also still works. So while it's possible to do this, like I said, it's not the preferred means of calling methods on objects. The first method here is the way you should be doing this. And so I recommend that you stick with this format. Now, there are a few special methods that we can provide in order to control various aspects of our classes. One of those is the init method. And do notice that there's 2 underscores both before and after the word init. This method is used to modify the initialization of our object. So for instance, if we were to write a person class, I say class person, colon, and we wanted to initialize each instance of a person using their first and last name, then we would write an init method that takes 3 parameters. The first, of course, is self, which is the current instance of the object being operated on. And the last 2 parameters will be first and last name. And we're going to define these because we specifically wanted to initialize our objects using the first and last name. And now, to actually add the first and last name to our instance of the person, we're going to define 2 attributes for this instance. So I write self.firstName, where first name is going to be the attribute that we want to use to store the person's first name. So I'll bind that to the argument first. And then similarly, I'll do the same for last name, self.lastName, and we'll bind that to the argument last. And now when this method is called, the first and last name that are passed here will be attached to this instance of person. Also, when we create a new instance, The init method here will require us to specify the first and last name. Before we do that, however, let's also add another method here that will print out the first and last name of the person. So let's run that block, and then now we're going to finally create an instance of our person. So I'm going to use the variable name person, then I'm going to say equals, and of course our class name now person. Because we've modified the init method, we are now required to specify the first and last name here as part of the argument. So I'll write Arthur Pendragon here. And then to see that this worked, let's actually call our full name method on this instance of person. So again, in order to call the method, I write our instance person dot and the method name full name. And again, I'm not passing any arguments here since person will automatically be applied as the first argument itself. And when we run this block, we see that Arthur Pendragon is printed in the output. So with the init method, we've modified how instances of our person class are constructed, and we've also bound two attributes, namely first name and last name, to objects of type person. And we see with this example how we can set both those values as well as recall them and use them using the full name method. So in that last example, we saw how we could add variables or members to our class person. These are called instance variables because they belong to a particular instance of the class. That means that every person object that we create will have its own first and last name. Now, there's another type of variable that a class can contain, and those are called class variables. Class variables are part of the class, but they are shared by all instances of the class. So to be clear, class variables differ from instance variables in that a class variable will have a single value for all instances, while an instance variable will have a potentially different value for each instance. Now, to define a class variable, we simply add a variable to the class definition, just like we did for methods. So I'm going to recreate our class, myClass, and then I'm going to define a class variable. So I'll call this CLS underscore VAR. I'm just going to bind it to a string, class variable. And then I'm also going to define the init method, which is going to take self, of course. In this case, I do want to give it a parameter a so that I can show you the difference between a class variable and an instance variable. So here in the init method, we'll simply write self.instVar is equal to a. Okay, so now let's create two different instances of the class, and we're going to provide them with different values for the instance variable. And now we're going to print out a couple of things here. So I'm going to paste a block of code. Now these 4 lines I've just inserted will print out both the instance variable and the class variable for each object, object 1 and object 2 here. We see in the output here that the instance variables are indeed attached to each instance, obj and obj2, separately. Also, we see that both instances were able to access the shared class variable and print it out here. Now, if we modified that class variable and then printed it out again using each instance, we see that both objects reflect the change. Now, note that when I set or rebound the class variable, I did this using the class name. If you were to try to rebind a class variable using an instance of the class, you would actually create an instance variable with that same name. Now to see this, let's actually use obj to set the value of class var. Then we'll print out class var using both instances. Now when I run this, we see in the output that the first 2 lines that print use the modified class variable that we set in the first line. The last 2 lines in the output are different now. obj is using its instance variable that has the same name as the class variable, and obj2 is using the class variable here. And just to drive the point home, if we tried to set class variable again using myClass, and then print out the lines again, you see that obj still uses its own instance variable with the same name, and obj2 uses the class variable itself. Now, as we just saw here, objects can be modified even after the class definition. So in the line here, obj.class variable is equal to the string, we're actually adding a new instance variable to this object. Similarly, we could do the same for class variables. So I can write here myClass.new class variable and bind that to a string, class variable added after class definition. And then I'll paste some print statements here, where the first line simply prints out the previous class variable, which we see is modified class variable again from the previous code block. And the last 3 lines all print out this new variable that we've created using myClass, obj, and obj2. So with this, we see that our classes can actually be modified on the fly. So to wrap up this notebook, I do want to make a few comments on visibility. Now in Python, all class members are public, meaning that everything that's in a class is visible to anyone who's using that class. There is a convention, however, that if a name begins with an underscore, it's considered to be private and should not be directly used outside of the class. Now, it's not enforced. As I said, it's a convention. So it's recommended that you follow this convention because directly using functions that begin with underscore may have unintended consequences unless you know exactly what each of those functions is doing.